Today we're going to be talking about solving square root equations. What I want to point out is that square roots are just like any other function. Our basic rules for solving functions kind of follow the same pattern, and you're going to see this pattern as you go through all the different types of functions. The rules that we're doing today also apply to all of the other roots. You know, we studied radicals, and we know that there are other roots other than square roots. There are cube roots and fourth roots, and all of this applies to them as well. So today, we're going to talk about solving square root equations. So if I have the square root of x plus 3 minus 5 is equal to 2. And I want to solve this equation. I need to start thinking about kind of my order of operations. Remember, all solving is undoing the order of operations. And the last step in the order of operations is the addition and subtraction. So generally, when we're solving equations, those are the first things that we want to get rid of. However, when we get these other functions thrown in here, what happens is sometimes some of that addition and subtraction gets trapped inside. So it's trapped inside of a grouping symbol. So we can't get rid of it until we get rid of the grouping symbol. So the first thing that we always have to do is we have to isolate the radical, okay? I can't get rid of anything inside the radical until I get rid of the radical, but I can't get rid of the radical until I've gotten it by itself. So I need to isolate the radical, and this is true for square roots, cube roots, fourth roots, any root you can think of. We want to isolate the radical. Generally, that means that we're going to have to add or subtract. Occasionally, if there's a coefficient out front, we may have to divide. But we want to get whatever the radical is and whatever is inside of the radical, we want to get rid of anything that's not inside the radical. So for this particular problem, that means I've got to get rid of the minus 5. So to move this over to the other side and get rid of it, I have to do the opposite. So I'm going to add 5 to both sides. And when I do that, minus 5 and plus 5, of course, cancel each other out. So all I'm left with is the square root of the x plus 3, and that's inside the radical. Now over here on the other side, 2 plus 5 is equal to 7. So after we have isolated the radical, our next step is going to be to get rid of the radical. And just like every other solving equation thing, to get rid of something, you have to do the opposite. You have to do the inverse. And we have discussed that the inverse of the square root is the square. And so we need to square both sides. We're going to do the opposite power. Remember, the opposite of radicals is a power. So the opposite of square root is to square. The opposite of the cube root is to cube. So we do the opposite power. Now, this is where we have to be very careful, because we have to do the whole side to that power. And we have to do the whole side to that power. It's not individual things that get squared. It is the whole side that gets squared and the whole side that gets squared. Now over here we get lucky, because the square and the square root cancel out. It was designed that way. That's why we did the opposite power. So all we're left with on this side is just the x plus 3. Over here, the only thing we have on this side is 7. So we need to square 7, and 7 squared is 49. All right, so if we have 49, now this looks much more manageable. This is just a linear equation. You guys have been doing linear equations for a while now. So the third step is to finish solving. Sometimes we get left with another type of equation. We might be left with a linear equation. We might get left with a quadratic equation. We learned quadratics. Quadratics keep popping up forever. But we need to finish solving whatever equation is left. And so when I look at this problem, the only thing I really have left to do is to get rid of this 3. 3 is being added. So the opposite of that is to subtract. So I'll subtract 3 from both sides. So this side, it gets rid of it. It balances out, though, because we subtracted it from both sides. 49 minus 3 is 46. And so I got that x was equal to 46. We do have a fourth step that we need to discuss with square root equations. We have, when dealing with square root equations, we have what are called extraneous solutions. So our fourth step is going to be to check for extraneous solutions. Now, just from a English standpoint, extraneous, kind of extra, extra solutions. Sometimes with square roots, we can do all of our math correctly, but we actually get an answer that does not work in the problem. And there's a reason for that. If you recall, when we do the square root function, we have to take the positive output. The positive output, because if we took the negative output, it wouldn't be a function. Remember, it wouldn't pass that vertical line test. And so we got rid of the bottom half of the equation, and so that way it would pass the vertical line test and be a function. But when we solve equations and such, we also know that for practical purposes, the square root has two outputs. It has a positive and a negative. And so sometimes when we're solving these equations and we're working backwards, we get a number that is the result of if we had taken the negative square root. But the thing is, this is the square root function. We're not going to take the negative square root. We're going to take the positive square root. So any answers that would work if we had taken the negative square root aren't actually going to work in this problem. And so that means that we always have to take our answers. Even though we did brilliant work here, we always have to take our answers and make sure that they actually worked. So I'm going to take 46 and plug it into the original problem. 46 plus 3 is 49. And then the square root of 49 would be 7. Not negative 7, just 7. And then 7 minus 5 would, in fact, equal 2. So 46 does work. It does not have an extraneous solution. But that's something that you always want to watch out for. Let's look at another example. So let's say that we have the square root of 2x plus 1 plus 5 is equal to negative 2. No. Let's say negative 7. There we go. If we have an equation, we said that our first step is always to isolate the radical. So here's my radical. All of this over here, the 2x plus 1, everything that's inside the radical has to stick around. So to isolate this radical, I'm going to have to subtract 5. So if I do minus 5, that's going to give me the square root of 2x plus 1 is equal to negative 12. And then we said that our second step, after we have isolated the square root, is to actually get rid of the radical. So we're going to do the opposite power. And it's a square root, so we'll do the opposite power, which is to square it. So when I square the square root, it cancels. I get 2x plus 1 is equal to, and then negative 12 times negative 12 is positive 144. We said that our third step is that a lot of times we're going to get left with some kind of equation. So if I've got 2x plus 1 equals 144, I have to finish solving. So I'm going to finish solving, and that's going to be minus 1. So 2x is equal to 143, and then when I divide by 2, I get that x is equal to, let's see, 71.5, or we can leave it as 143 halves. Exact answers are always awesome. Okay, so then we have an answer. Beautiful work. And I've got an answer. Now, I need to remember my fourth step. And this isn't just being paranoid to check to see if our answer works. We are checking for extraneous solution. I'm very confident in my steps. I've been doing math for a long time. I'm pretty confident I did this right. I have to check my answer because I have to watch out for extraneous solutions. I can do brilliant work and still get an answer that doesn't work. And so I want to plug back into this problem. So I'm going to take 143 over 2 and plug it back into this problem. So 143 over 2 times 2. Well, the 2's cancel out, so I just have 143. That's nice. 143 plus 1 is 144. And then the square root of 144 is 12. And 12 plus 5 is 17. 17 does not equal negative 7, like at all. And this is what I was talking about. If we had taken the negative square root of 144, if we had said that the square root of 144 was negative 12, negative 12 plus 5 would have equaled negative 7. But because this is the square root function, we can't take the negative square root. We're just taking the positive square root. So 12 plus 5 does not equal negative 7. This is what we call an extraneous solution. It does not work. So this problem actually has no solution. There's no answer for this particular square root function. This is extraneous. So it's an answer that I did all of my work right, but when I plug it back in, it's not actually going to work. So you want to watch out for those problems. Let's look at another example. So one more example. If I have square root of x minus 3 plus 2 is equal to x. I have two x's. And in general, when we've solved problems before, you've always wanted to get your x's together. But we want to make sure that we are following the rules of dealing with, functions, when we've got things inside of things and different functions going around. Our first step is always to isolate the radical. That does not change. Even if there's an x inside the radical and an x outside of the radical, we are still going to have to isolate the radical. So we are still going to have to get rid of that 2. The 2 is going to have to go. And I think before we get started, I think I'm going to change this 3 to let's make it minus 1 instead. No. Let's make it plus 9. There we go. Plus 9. So if square root of x plus 9 plus 2 is equal to x. So I still want to isolate. So when we isolate this, we have to get rid of the 2. Nothing changing. You see, this is very repetitive. Equations are very repetitive. So if I subtract 2 from both sides, the 2's cancel out. And then we are very helpfully left with just the square root of x plus 9 is equal to. Now here is where some people might start to freak out, but don't. This is actually less work for us to do. Normally we would have to take whatever is here and subtract 2 from it. But since it's x, I can't subtract 2 from it, so just leave it alone. It just works out to be x minus 2. And that's totally okay. Our second step does not change. Our second step is going to be to do the opposite power. So we are going to make sure that we do the opposite power. So when I take both sides and square it, and both sides and square it. So I took this whole side and I squared it. And I take this whole side and I square it. Please note, I do not square things individually. The whole side gets squared and the whole side gets squared. That's very important. Square and square root cancel each other out. So on this side, I'm left with x plus 9. This side, however, I need to remember how to handle this kind of polynomial. there's not a distributive property of exponents. I can't distribute over this minus sign. So I have to remember that when I have x minus 2 squared, it's really x minus 2 times x minus 2, because that's what powers are. It's repeated multiplication. And so that means that I'm going to have to multiply this out, either with FOIL or box, whichever your multiplication method of choice is. I have to multiply that out. X times x is x squared. I get minus 2x and minus 2x, which is minus 4x. And then I get negative 2 times negative 2, which is positive 4. So this gives us a particular type of equation. We said our third step is to always finish solving. We need to make sure that we finish solving, but we have to remember all the ways to solve. What kind of equation is this? It has a square in it. That's a quadratic. So we have to remember our options for quadratics. We've got completing the square, we've got quadratic formula, we've got factoring, we've got graphing. There are lots of options for solving quadratics, but all of them require this to be equal to 0. So we want to remember all of our rules for solving. This finish solving step is wide open to all kinds of different types of equations. They can be linear, they can be quadratic. You never really know until you get there. So I want this to be equal to 0 though, so I'm going to subtract x from both sides and subtract 9 from both sides. I'm going to get those to cancel out and get 0. I've got x squared, let's see, this will be minus 5x and minus 5. All right. This is not going to factor, so we're not going to get this to factor out. But we can use the quadratic formula. If we've got a is equal to 1, let's see, b is equal to negative 5, and c is equal to negative 5 as well, we can put this into our quadratic formula. Now, the other thing to remember is that when you do quadratics, you get 2 answers. So we're not going to have just one answer to check to see if it's an extraneous solution, but we're going to have 2 answers to check and see if it's an extraneous solution. So let's get to town. So if we remember our quadratic formula, it's opposite of b, plus or minus, that's how we get the 2 answers, square root of b squared minus 4ac all over 2a. So let's find our discriminant first. So if we take our calculator, it's always nice to have a handy dandy calculator to help you out. All right, so on our calculator, let's figure out. So we've got b is negative 5, so negative 5 squared minus 4 times 1 times negative 5. And that gives us our discriminant, and it's 45. Well, that's good. It's positive, so at least we know we're not dealing with an imaginary number. So 45 plus or minus. Now the opposite of negative 5 would be positive 5, and 2 times 1 is 2. This can reduce. There is a perfect square that will go into 45. This is 9 times 5, so the square root of 9 is 3. So we do end up with 5 plus or minus, let's see, that'll be 3 on the square root of 5 all over 2. So we got 2 answers. Now we need to check our answers and plug them back in and make sure that we get, this answer. So we want to plug it back into the original, which is not going to be pretty if I don't use my calculator. And this is why having a calculator to help us out with some of these computations is delightful, because we cannot skip the 4th step. There's just no getting around it. Like I said, I'm very confident in my work that I did these right. I'm not checking because I'm worried that I did a step wrong. That's not what I'm doing. Checking for an extraneous solution is about making sure that both of these answers actually work. If it was the result of getting the negative square root of this, then it's not going to work. So I'm going to take my calculator, and this is, again, how we check answers when you put things in the calculator. I want to put in the original answer. So I'm going to enter in 5 plus or minus the square root of 45 over 2 in here and get a decimal for this side. And then I'm going to compare it to the decimal that I get on this side. So first, let's see, what is 5 plus the square root of 45, enter, divided by 2. Okay, so that's roughly, so x is 5.854101966. Okay, so when I enter it in over here, I want to make sure that I get the same thing. So I'm going to take that, so I'm going to take my answer, that's x, plus 9, enter, take the square root of that, and add 2, and I got 5.8541. Oh, it did in fact match. So the plus version of this is definitely an answer. The plus works. Now we need to figure out, does it work for the minus answer? So let's clear all this out and start fresh. So first let's figure out what is 5 minus the square root of 45 divided by 2. Okay, so the negative answer, the minus the square root of 5, is negative 0.85410196662. So that's what x is. So now let's try x plus 9. Take the square root of that and add 2. Ugh. 4.85 does not equal negative 0.85. So this must have been an answer that we got if we took the negative square root of this one, because those two answers do not match. So for this problem, that tells us that the positive answer works. The negative answer is an extraneous solution. So there is actually only one answer. The only answer is 5 plus 3 square roots of 5 over 2. Only one of the answers worked. Sometimes both answers work. Sometimes neither of the answers work. There's not really a way to tell unless you check it. So please make sure that you are checking for your extraneous solutions.